Hello, smart mathematicians. Let's do question 11.2.1. In the diagram, PK is a tangent to the circle at K. So this is PK. It's a tangent to the circle at K. Chord LS is produced. Chord LS is produced to P. And then N and M are points on KP and SP respectively. N is a point on KP, and then M is a point on SP, such that MN is parallel to SK. MN is parallel to SK. Chord KS and LN and the line segment LN intersect at T. Prove giving reasons that angle K4 is equal to angle NML. Right, I want us to just discuss this right before we answer our questions, like we usually do. Okay, let's just discuss this right, and then after that we're going to answer the questions. We are given that PK is a tangent. PK is a tangent. I want us to use this information. Think about the tangent theorems. Do we have these tangents being drawn from an external point? No, we don't have two tangents drawn from the external point here, so it's fine. All right, do we have a tangent in the chord? Yes, we have a tangent in the chord because we have PK and what? And KL and also KS. KL is a chord, KS is a chord. So we think of the tan chord theorem. Do we have a line from the center? Or do you have radius or diameter? Not yet, we haven't seen anything about that. So the only tangent theorem we can think of is the tan chord theorem. Okay, so this forms an angle between the tangent and the chord. So this angle K4 should be equal to this angle here. Okay, so K4 is equal to angle S1. And then also, this is the angle between the tangent and the chord. So it means angle, let me call it PKS, is equal to angle KLS. So this angle is equal to this angle. It's also a tangent tan chord situation there. Let's go to the next piece of information. Chord LS is produced. Chord LS is produced to P. Then N and M are points on KP and SP respectively, such that MN is parallel to SK. Right. Now, if you check here, parallel, think of the proportionality theorem. You can see proportionality theorem here. For triangle L, N, M, this is the triangle that we don't know, maybe, using this information, we may be asked to use, or may be required to use the proportionality theorem there. And then chord KS and LN intersect at T. MN is parallel to SK. Right? Before you even think of complicated theorems, you think of what? Of the geometry of parallel lines. Think of corresponding angles, alternate angles, and co-interior angles. If you check here, this angle here, S1, is going to be equal to this angle NMS or MNL. So these angles are equal. So these three angles are equal. This angle, and this angle. You can see also alternate angles here. This angle is equal to this angle. These are alternate angles. Co-interior angles. Yes, you can think of co-interior angles. What else? I think we've discussed a lot when it comes to this, right? Now, let's try to answer the questions that are there. It's not like we've discussed everything. We've discussed some of the things, but we find that we may need also to do more when we look at the questions, okay? Now, let's go to the questions. We are required to prove that K4 is equal to NML. Like we discussed, we can easily see that K4, this is K4, which is this tangent and then chord. We're forming an angle between the tangent and the chord there, K4. is equal to angle what? Angle S1 there. Okay, why? Because of the tan chord theorem. So K4 is equal to angle S1 because of the tan chord theorem. But we also said that angle NML, angle NML is equal to angle S1. You remember that? We discussed this because these angles are corresponding angles. Since MN is parallel to KS. So if you check here, K4 is equal to S1, NML is equal to S1. So it means that K4 is equal to angle NML. So we can say since we have angle K4 being equal to angle S1, which is equal to angle NML, therefore angle K4 is equal to angle NML. So therefore angle K4 is equal to angle NML. So that's what we're supposed to do there. Thank you. We're going to meet when we do question 11.2.1b. This was question 11.21a. So we will do 11.21b in the next video.